All right, hey everybody. Hope your day has been going well. It is time for Cloudy with a Chance of Learning. We're going to talk about something pretty fun here today. It's tropical funnels. And I say fun, and we're talking about funnels and tornadoes, because tropical funnels typically actually don't even make contact with the ground. So not as much of a concern as a tornado, but sometimes they can cause a little bit of damage. And we're going to be talking about that all throughout today, as well as what they are and how they form. Is it really that much different from a tornado? We're going to answer all of those questions for you, of course, and any other questions that you may bring our way. Of course, yesterday we talked all about tsunamis with meteorologist Megan Massey. That was a ton of fun. And today we're going to go back into kind of more meteorology again with these tropical funnels. Now, a tropical funnel is a funnel, or in other words, an area of rotation that's forming in a rapidly rising layer of warm and humid air that has a bit of vorticity to it. So there's a word in there that maybe not everybody knows. Vorticity. What could that be? Well, that actually has to do with rotation, an area of spin in the air as it's rising. That can cause a funnel to form as that moisture in warm air cools and condenses. Remember, that's how clouds form. Cools and condenses while it rises, and that rotation can cause that column of air that we're talking about to stretch and cause that rotation. Almost kind of like, it's not the best analogy, but like a yo-yo when it goes down and it's spinning. It's almost like it's getting stretched out, like when the string takes it down. So, yeah, it's just kind of stretching out there. It's not the best analogy, but I'll see if I can find a better one here in a moment. So, that's what a tropical funnel is. Typically, they form in more tropical environments. We actually had some tropical funnels in South Texas last week on Friday. We had some form in southern Bee County and then into southern portions of Live Oak County. This was early in the morning. This was even before sunrise on Friday morning, and we had tornado warnings issued from those. Now, none today. If you just heard me say tornado warning, don't worry, not today. But this was Friday morning for southern Live Oak and Bee counties because of tropical funnels where it looked like they may have been able to make contact with the ground, because sometimes that can happen and we can end up with weak tornadoes. Tropical funnels are actually more common in the early morning hours along the Gulf and along coastal areas as a whole. Somewhere where they're really common is actually right off the coast of the Florida Panhandle, stretching all the way over even towards the Galveston region, just off the coast. If you've ever been down to the coast yourself, and maybe your family took you to the beach, you may look out across the water, and sometimes early in the morning, if you're out for a walk early on, you may see a little shower, and as that shower is intensifying rapidly, you may have one of those tropical funnels form, and that could end up being a water spout. That's typical with how water spouts form. Fair weather water spouts. There's two different kinds of water spouts there, and a fair weather water spout forms typically from these tropical funnels. So I see a few people finally joining in. Ainsley says hi. Hello to Ainsley. Joanne Wilson says hello. Hello to you as well. I hope you're all doing well today. So these tropical funnels, they form in areas where we have a warm and humid air that has a little bit of vorticity to it. Remember, vorticity, that rotation, vorticity has to do with spin. And typically more tropical environments, but they can form in areas even further north. Sometimes they've had this in Amarillo, Texas. They've had this in Jonesboro, Arkansas, the very northeast corner of Arkansas, which is a state that doesn't even border the coastline. So this can happen in places other than just along the coast as long as you have a ton of humidity. And think about last Friday. Think about how humid it is now outside, how much moisture is in the air. We had a ton of that Friday morning, and that's why this was able to happen. And that's why I wanted to bring out this topic, because it's something that happened this past week right here in South Texas. So they're more common. Again, it can happen in the afternoon too, these tropical funnels, but they're more common in early morning showers and storms and they typically occur as that shower or storm is intensifying. So we've talked about storms in the past. These form typically when there's a really strong updraft. An updraft, remember, that's the part of the storm that's growing whenever the storm's getting bigger. And whenever the downdraft takes over, that's when it's raining really heavy. That's when all that air that rose high up into the storm and the downdraft occurs, that's when all of it goes back down to the surface. And it gets really windy and we have a ton of rainfall. But as that cloud is building and growing and getting larger before the downdraft starts picking up, that's the updraft. So the air is rising, cooling, and condensing. And if this is happening very rapidly, if we have a lot of quick motion to it, that's when that little bit of vorticity could get stretched. So we have the air rising. Here's the base of the cloud. That vorticity, that area of spin, gets stretched. And sometimes, as it tightens up and goes down, it'll make it all the way down to the surface. And that could lead to a tornado warning. But these tornadoes typically aren't as strong. And we're going to talk more about that here in a second. These are typically a little bit more on the weaker side. So again, these are more common in early morning showers and storms. And just as I mentioned a second ago, they form in a similar way to how many waterspouts form. That is, fair weather waterspouts. And we're going to look at something here in a moment. We're going to look at photos, and we're going to talk about storm structure and how the storm structures are different when we have an actual tornado compared to when we may be dealing with something just like one of these tropical funnels. So really interesting. Joanne says she loves these live learning adventures. Joanne, thank you. You know, we're happy to be able to do them and keep the learning going as far as the summer is concerned and as we continue to go through these weird times all together. Ainsley says she enjoys them as well. Ainsley, no problem. You're one of our loyal viewers, I know, for our Cloudy with a Chance of Learning. I'm glad you're still joining us here today as well. So, again, these tropical funnels, they form in different ways compared to tornadoes. Tornadoes, we typically have more storm structure, and we're going to look at a photo with storm structure in a second. We've talked about storm structure in the past with supercells. If you missed that lesson, it was a few weeks ago. Of course, you can find that on YouTube or Facebook. Just look up our lesson on that with our Cloudy with a Chance of Learning playlist on YouTube. Typically, it's easier to find those on YouTube. Again, storm structure, we're going to talk about that here in just a moment. Typically no significant storm structure with these tropical funnels. Again, it has to do with the storm rapidly intensifying, typically early in the morning. And they're known to have short lifespans. They don't typically last too long. If you watched Friday morning, you will have noticed that I was saying whenever the tornado warnings were issued, I kept telling people, listen, this is not going to last very long. I don't think that these tornado warnings are going to move very far. They're going to be very short-lived. And that is because I knew these were tropical funnels. And once that downdraft gets going within a storm, or it gets even a little bit too breezy, because typically you need calmer winds for these tropical funnels to form as well. If it gets too breezy, it can kind of allow that spin, that area of vorticity. There's that word again. We're going to use it a lot. Remember, vorticity has to do with spin. It will allow that area of vorticity to kind of get wiped away. Here's a comparison here. Let's say you just finished taking a bath and you pulled the plug and all the water is going down the drain. You'll notice that spin, that area of vorticity, as the water is going down the drain. But if you were to take some of that water in the bathtub and splash it towards the direction of the drain, that little area of spin, that little vorticity, or the little tornado that you're seeing, I guess you could say, in the water would disappear for a moment before it was able to reform. That's what the wind is. The wind is that water splashing over. So if you have a bunch of wind, it'll stop these tropical funnels from being able to stay going. So think of it this way. We have this updraft. Remember, that's the rising air in the shower in the storm. That's what causes that area of vorticity, or the spin, to stretch. But once the downdraft, that's the heavy rain coming down, and then the strong wind sometimes, remember, the wind, that's the key word there, that wind will sweep out and push out, and it'll cause that area of vorticity to mess up like that sloshing water in the bathtub. If you have any questions about that, guys, send that my way. Joanne asks, what if there's a lot of those tiny funnels in the sky? Joanne, that's possible. That will actually happen sometimes when you see multiple water spouts out over the water. That can happen from multiple areas wherever we have that strong, fast rising air. And you'll get lots of these little areas of vorticity to form. And you can end up with multiple water spouts. I saw that all the time. When I worked in Biloxi, Mississippi, right off the coast, especially towards the islands, you'd see multiple water spouts. It typically wasn't just one. You'd have multiple water spouts forming. And Joanne, that's a great question. These little tiny funnels, sometimes there's multiple of them. And again, has to do with tropical funnels. And typically that's when you have larger showers. But as long as, if the downdraft can stay further away from that updraft, you can end up with a good amount of those funnels. And sometimes they could stay down longer, but very typically they will actually have very short lifespans. So in other words, they'll form and then disappear pretty quick. So winds are typically less than 70 miles per hour, so typically weaker. Most tornadoes are typically stronger than that. And they rarely reach the surface. But if they do, they can cause minor damage. So even if you do just have a tornado warning issued from a tropical funnel, it's still important to take it seriously and get to that lowest area of your home, the most interior room. We talked about the places where you need to go during a tornado warning in a previous Cloudy with a Chance of Learning, so be sure to go back and check that one out too. But it's still important to take them seriously even when it's a tornado warning from a tropical funnel. So again, it's very rare that they make it to the surface, but still possible, and they could still do damage from that. And Robert says, and you don't have to be a kid to learn a thing or two. Robert, yep, that's true. You know, some of these things, not even everybody knows. Not just kids don't know about them. You know, a lot of this stuff I didn't learn about until I was in college, and then sometimes when I was younger, working in the industry. You know, I've been working in the industry now for about 8 years, and I'll tell you, those first 3 years, I learned a lot about things that I had no idea existed, and actually tropical funnels was something I didn't know about. My first experience with tropical funnels was in Jonesboro, Arkansas, and I immediately called my chief meteorologist and said, hey, I think we got to get a tornado warning. Someone just sent me an image of a tornado forming, and he notified me and said, yeah, that's a tropical funnel, and here's how those form. We're all learning constantly. Think about meteorology is a science. And with science, you're constantly advancing and constantly learning. There's always something new to learn. Kids, we talked about this yesterday too with tsunamis. In a scientific field, there's always more to learn. Never feel like you've already figured out everything, because there's more to learn along the way. So a little bit of a sidetrack there, but you know, I always want to bring that home and remind y'all about it. So again, back to tropical funnels. They typically are less than 70 miles per hour and rarely reach the surface. Now, we're going to look away from tropical funnels for a second. This is actually a tornadic storm. Now, this is going to be the type of storm structure that you would see when you have one of those long tracking tornadoes. This is not how tropical funnels form. This is storm structure. We have our updraft, which is occurring here. This is your updraft. Oh, I've got a... Hold up, I have a white arrow. Let me change the color to yellow. That way we can see it a little bit better, guys. Give me 1 second. Well, it may not let me change the color. Here, I've got another one here I can use. So, here's our updraft. That's the rising air within the storm. Here's your downdraft. There's the rain and possible hail. And you'll notice right here, this is a wall cloud. Now, we've talked about this in past lessons, so this is kind of a review. This is where our tornado would typically form, is within the wall cloud. That's a lowering in the clouds where we could have a tornado occur for a long tracking storm. This is storm structure. Again, we talked about it in previous lessons, but I want to give a little bit of a recap. Mason in Bernie, Texas, 7 years old, says hello. Mason, welcome to Cloudy with a Chance of Learning. I'm glad you could join us for today. If you missed a little bit early on in the lesson, don't worry, we'll talk more about it. You can always go back and see what you may have missed while either watching YouTube or waiting till the end of our Facebook lesson here. So I want to erase everything because now that was a little bit about storm structure. And by the way, you know what? Let me bounce it back because, guys, I do want to show one more thing here. Here's your, I talked about wall clouds, which is where tornadoes form. That's a wall cloud right there. That's an in-person view of one. That's a real-life example. That is that lowering in the clouds. Now, notice what you see when we have a tropical funnel. You're not really seeing that lowering. It's just kind of a flat cloud base, and you'll notice how low the cloud base is. That's important to know too. So we talked about warm and humid air being associated with these tropical funnels forming. Typically, the cloud deck, or the area where the clouds are, is a lot lower when we're dealing with tropical funnels because of how much moisture is in the air. So with all that moisture, you can typically get that cooling and condensing. We call it the LCO, the lifting condensation level, is the bottom of the cloud. And that's going to be where we would have our tropical funnel occur. Now this first photo is from the National Weather Service in Amarillo. So this is a tropical funnel. Remember, I told you, you don't necessarily have to be right up against the coast. You just have to have a really humid environment, and it must have been a humid day in the Panhandle at this time. But they're more typical closer to the coast because more typically it's humid. So tropical funnel in the Panhandle there, that's an image of one. And here's an image of a waterspout that formed from a tropical funnel. Now this is actually a waterspout that formed on a lake. How interesting is that? So you don't just have to be along the coast to have a waterspout form. This is actually a reservoir that is about the size of maybe a little bit bigger than Calaveras Lake. So it's not a very large lake, but you can still have a waterspout form on it. This is on the Ross Barnett Reservoir in the Jackson, Mississippi area. And this is actually not far from where I grew up. This is a waterspout that formed from a tropical funnel, and you can see that the storm structure is lacking. You're not seeing that storm structure like what you would see with how a regular tornado would form. And guys, if you have any questions, please ask them. I'd be happy to answer them for you. But this one that was in the Jackson, Mississippi area, that formed the waterspout. That waterspout only lasted for 15 minutes. Remember what we said, these are typically short-lived. They don't typically last very long, and it was short-lived, and it didn't cause any damage because remember, when these do make contact with the ground, they're typically weaker. And this did make its way over towards land and then eventually fizzle out. But again, the wind will cause it to fall apart. You also have the downdraft and the rain and all sorts of other factors that cause them to not be able to last for a very long time. So sometimes they're straight up and down like this. Other times they are a little bit more curvy like this one. Now this was likely the end of the life cycle for this tropical funnel. Once it starts to lean over to the side like that, that lets us know there may be a little bit of wind starting to push it, maybe. Sometimes it's not necessarily the wind, it just has to do with how the spin is going. Think about it like a top. Sometimes your top isn't spinning straight up and down. Sometimes it wobbles a little bit, your top does, whenever it's starting to slow down. Well, maybe that tropical funnel started to wobble a little bit. But that's your best little answer there, I guess, to what I'm trying to explain. Joanne says she grew up in central Arkansas and was lots of crazy weather. Joanne, I agree. There was a lot of crazy weather up there when I worked in northeast Arkansas myself. So I know exactly what you're talking about there. It's amazing how different parts of the country we can have different kinds of weather, but then sometimes you can have the same kinds of weather in different parts of the country, even though you wouldn't expect it. So pretty cool stuff. Kind of like how here in San Antonio, you don't really expect snow ever, but sometimes you do get it. So Robert says, meteorology fascinates me. I've even watched YouTube videos on how to read natural signs of weather change. It's pretty cool. Robert, weather has fascinated me since first grade. I knew I wanted to be a meteorologist since first grade and kind of followed that path. And it continues. I continue to learn again. I have not stopped learning. That's the beauty of science. You're always learning something new, and every once in a while somebody will tell me something in the weather community, and I'll say, wait, what is that? And you never know. You never know what you're going to learn. Every day brings something new. It's not always just cut and dry like sunny and hot. Sometimes you get a little bit of more activity and a little bit more learning as you go along. So, typically in heavy early morning showers, as the shower's forming, that's where we see the tropical funnels form, typically closer to the coast. They can form water spouts over the water. That's where we typically see that those tropical funnels make contact with the ground. Remember though, not all water spouts form from tropical funnels, but tropical funnels can form water spouts. Just remember that. Some water spouts are associated with more of that tornadic storm structure and can be actually very dangerous and can be just as strong as a tornado on land. So it's important to remember water spouts can be very, very dangerous, and only some water spouts are not as strong, like ones formed from these tropical funnels. But tropical funnels, when they make contact with the ground, remember, maybe 70-mile-per-hour winds, that's dangerous. That's deadly. It's always important to stay away from any type of tornado, no matter how it may have formed. So that leaves us with the end of Cloudy with a Chance of Learning, talking about tropical funnels. I hope y'all learned a lot. This has been an exciting talk for me because anything tropical related, I've always been fascinated by it. There's a lot of energy coming from the more tropical environments. We may talk about the ITCZ next week too. That's an area near the equator where we have constant thunderstorm growth all the time, and I think that'd be a fun talk. I'm going to put that down for next week. But as far as this week is concerned, let's see what's on the schedule. Now, it does say field trip to the Museum tomorrow. Unfortunately, we have to push that back to next week. So the Museum talk, unfortunately, isn't going to be for tomorrow. We're going to push it to next week. Tomorrow, we're going to, Weather Chief Bill Taylor is going to talk about fire tornadoes. Pretty cool talk. Yes, you can have tornadoes form in fire, and it's kind of similar to dust devils. I don't know if we ever talked about dust devils. Maybe that's another topic I need to put down for next week. We talked about tsunamis on Monday. Of course, today was tropical funnel clouds. What is CAPE? That's convective available potential energy. But what is that? That's a lot of big words. We're going to talk about that on Thursday. And then field trip to the San Antonio Zoo on Friday. It's a lot of fun. I can't wait. Last week, we had the giraffes on from the zoo. It was a ton of fun. Guys, if you missed our field trip last week, our Cloudy with a Chance of Learning with the San Antonio Zoo and the giraffes, you need to go back and watch it. It's on YouTube. It's on Facebook. I learned so much about giraffes. I had no idea. And, of course, we had them on camera. They were feeding the giraffes. They held the food away, the snacks that the giraffes were eating, and you got to see how long the giraffe's tongue was. And did you know a giraffe's tongue is purple? I mean, you can learn all sorts of fun stuff from that talk. Go ahead and check it out. Again, we have a playlist on YouTube where you can find all of those. So guys, have a wonderful rest of your day. It's going to be hot and humid today. It's going to be hot and humid pretty much for the rest of the week with not too much in the way of rainfall, unfortunately. Of course, Weather Chief Bill Taylor is on at 4, 5, 6, and 10 with the latest update to the forecast. Meteorologist Megan Massey is working on some web stories right now to talk about that 4th of July forecast, as well as what's the deal with the Saharan dust? Because we got more coming in later this week. Look for those on KENS5.com and look for us on KENS5, the CBS affiliate right here in San Antonio. Weather Chief Bill Taylor again on at 4, 5, 6, and 10, and then all the latest for news and weather at those times as well. Y'all have a wonderful rest of your Tuesday.